So suppose you have some circuit like this, and this isn't even that complicated. I mean, it's just got DC batteries and resistors, but still, there are a lot of currents to solve for here, and so it can get kind of complicated. So I'm going to show you how to do this. I'm going to actually set this up and then switch to a simpler situation and solve that, and then come back and solve this. So the first thing that we do when we have this, we have these resistors, and in fact, for this case, I picked all these things, R1, R2. Let's just say, I don't know, R1 equals 10 ohms, R2 equals 20 ohms. That's what's easy to remember. R3 equals 30 ohms, R4 equals 40 ohm, R5 equals 50, and then I have two batteries here. So let's say E1 for EMF is 5 volts, and then E2 is, I don't know, 7. I'm just making up stuff, people. I don't know what I'm doing. Okay, so the first thing we want to do is to write down the electric currents in all these branches that matter. And so if it's a situation like this, the current there doesn't really matter because there's no voltage drop. So I don't even care what that is. So let's just call this. I have to pick the directions to I1, I2, I3 comes down here. There will be some coming through here. Let's make that this way. I4, and then let's say this is I5. So 5 currents that I want to solve for. Now, there are two rules that we can use. There's the loop rule and the junction rule. So the junction rule says that if I have any place where 2 or more wires meet together, the current coming in has to be the current coming out. So right here I have a junction. So I'm going to write this as I1 equals I2 plus I3. Okay. Do I have another junction that's significantly different? Let's see right here. See, I don't know what that current is, so let's just leave that one alone. Let's use this one right here. I don't really know what that current is. And maybe I picked a bad problem. I just made that up. So let's say I3 plus I4 is equal to I5. Right? Because the current coming in is I3 and I4. The current leaving is I5. So that's 2. And you see where I'm going, right? If I have 5 things that I don't know, I need 5 equations. So I have 2. The other equations I can get from the loop rule. The loop rule says that if I go add up the voltages around any loop, it should add up to 0. So let's just start right here and go that way. If I go across a battery from negative to positive, it's a positive voltage drop. If I go in the same direction as the current, it's a negative voltage drop. So this is going to be E1 minus I1 R1, come down here, minus I2 R2 equals 0. So there's no voltage drop there. I get back there. Let's do this loop right here. So starting right here, I get minus I3, that's a 3, R3, and now it's going in the opposite direction of the current, plus I4, R4, and then plus I2, R2 equals 0. So now I have 4 equations. I need one more equation. Let's get this bottom one down here. Going around the loop, no voltage drop there. Here I have a minus I4, R4, and then I have minus I5, R5, plus E2 equals 0. So there's my 5 equations right there. So 5 equations, 5 unknowns. You could do solve this for I1, plug in everywhere you see an I1, solve for that one for I2, blah, 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 but who cares? I mean, I care. I don't say that I don't care, because I care, okay? But it's just tedious. No one wants to do that, okay? So let's do a super simple circuit and show you, because it's a little bit easier to set up. So here's a battery, a resistor, like that, and then I'll put a resistor right here, and then another resistor, and a battery. Yeah, so this is E1, R1, R2, R3, E2, and this is I1, I2, I3. So doing the same thing, I get I1 equals I2 plus I3, and then I get this loop is going to be E1 minus I1 R1 minus I2 R2 equals 0. And then let's do this loop right here. I get minus I3 R3 minus, because I'm going from positive to negative, E2, and then plus I2 R2 equals 0. So that's 3 equations, 3 unknowns. Now what I'm going to do is to rewrite these 3 equations. I'm going to rewrite them to make it a little bit more sense. I'm going to write all of these on the same side of the equation. So I'm going to subtract I1 and I2, 3 from both sides. I get I1 minus I2 minus I3 equals 0. This one, I'm going to move E1 to the other side. Actually, let's move those other things to the other side. I'm going to write this as this. I1 R1 plus I2 R2 plus 0 I3 equals negative E1. No, it's just plus. If I move those other sides, plus. And you'll notice here that I put I3, even though it's not there, I put 0 times I3. And yes, maybe you can see why. And then do the same thing over here. I'm going to move that to the other side. I'm going to write 0 I1 plus I2 R2 minus I3 R3 equals E2. So here I have these coefficients. Here I have I1, I2, I3, I1, I2, I3, I1, I2, I3, and then I have some values. If you use a little imagination, you can write this as the following matrix operation. I can write this as 1, negative 1, negative 1, R1, R2, 0, 0, R2, negative R3, times the vector I1, I2, I3 equals, and some people put this as a row vector, it doesn't really matter though, 0, E1, E2. So you see that if I write it in this way, if I take this and I multiply it by this vector, I take this row times that column, I get I1 times 1 times I1, negative 1 times I2, plus negative 1 times I3. I get that equation, and that should be equal to this value right here, which is 0. So this times that is that equation right there. Same thing over here. R1 times I1 plus R2 times I2 plus 0 times I3 equals E1. That's that equation. And the same thing down here. This is this equation times that is equal to that. So we've set it up as a matrix, and you may think, whoop-de-doo, that doesn't really do the same thing. And I see where you're coming from, and I get it. Okay. But what if I write this like this? R I equals V. I'm just going to call this the vector V, this the vector I, and that the matrix R. That's fine, right? And you may want to put arrows over it, whatever, if that makes you happy. You want to put lines to symbol their matrices or vectors or whatever you need to do. That doesn't matter. But the thing is, I want to find I. I want to find this vector I. I want to find the components of the vector I. I want I1, I2, and I3. But I have that R. If I could multiply this by the inverse matrix, R inverse, and I multiply this by R inverse, then this R inverse times R would give me the identity matrix. So this would look like this. It would be 1, 0, 0, 0, 1, 0, 0, 0, 1 times I1, I2, I3 equals some stuff. Right, because I have to multiply that inverse by these things, but I get 3 numbers, and those 3 numbers would be my 3 currents. So all I have to do is to find the inverse of this matrix, and then multiply this vector by that inverse, and that gives me my currents. Bah-ha-ha! There you go. Finding the inverse of a matrix is not easy. It's not hard, it's just tedious. Finding the inverse of a 3 by 3 matrix even is really complicated. Finding the inverse of a 5 by 5 matrix is torture. I would not wish that upon anyone, okay? But that's what we're going to do Python. So let me go ahead while I have my paper so I don't have to switch back. Let's take these equations and write them as in matrix form. Because I want to write this in a little bit different form. Okay, so you can't see it. I put it there. It is there. Okay, so I'm gonna rewrite those three equations. So the first one's this: I1 minus I2 minus I3 plus 0I4 plus 0I5 equals 0. The next one is 0I1 plus 0I2 plus I3 plus I4 minus I5 equals 0. Now the next one is negative R1 I1 minus, that's fine, minus I2 or R2 I2, that's R2, sorry, plus 0 I3 plus 0 I4 plus 0 I5 equals negative E1. 0 I1 plus R2 I2 minus R3 I3 plus R4 I4 plus 0 I5 equals 0. And then finally, I have 0 I1. I'm looking at my sheet and I'm like right here. Do I have an I2? No. Do I have an I3? No. So those are both 0. I'm just showing you you may think I'm just making stuff up. I'm not making stuff up. 0 I2 plus 0 I3 minus R4 I4 minus R5 I5 equals negative E2. So this is I can get these are my matrix values of R that I want to find the inverse of. Okay, so that's what I'm going to use. But let's jump back over here. Let's do this problem first and check that it works, and then I'll do the other problem, and we're going to use Python. Now, you know I like Python. You know that, right? I mean, if you know who I am, you know I like Python. Python's awesome. I usually use GlowScript vPython, Web vPython, because it's more transparent. It runs in a web page. You don't have to install anything, and it just makes me happy. Okay, but matrix operations are not built into that, and you could try to build your own matrix functions, and I considered it for a very long time, and then I said I'm not going to do that. And I know you think less of me, and that's fine. So I am using real Python, and I'm using Jupyter Notebooks Python. If you haven't used that before, it's not too difficult to get into. I will show you this. If you want to install it, the best thing to do is go to this site, anaconda.com, and you can download a distribution that has Jupyter Notebooks and it has the important modules that you need, so it's very easy to get everything set up. It used to be a really not fun thing to do, so it should work fairly painlessly. But with that, let me say one more thing. There's one nice thing about Jupyter Notebooks is we have these cells, and you can make a Markdown cell. So I can put this is a title, and then stuff, and I can put equations. I can do V equals, let's say, delta V equals IR. That's a latex equation, and anything, and then I can run that cell. You can click run or shift enter, and it puts it down as Markdown. So you can have this alternation of explanations and code. But I'm just going to do the code. And so the first thing I want to do is this: import numpy as np. And some people say numpy, and I totally get numpy. It's Python py, but it looks like numpy, and I think it's fun to say numpy. So I'm going to call it numpy. And if you don't want to call it numpy, that's fine. You call it what you want to call it. Okay. So I'm going to run that cell, and because in GlowScript vPython, Web vPython, our math operations are already built in, so you don't have to do this. It's actually the same kind of thing, but here you actually have to do that. Okay, so I have numpy. I already said what I was going to say. So let's just jump right into it, and let's make our R matrix as an array. So I'm going to say R equals np.array. Array is a function in NumPy that can make an array of stuff. And you can make an array of arrays. It's a lot like a list that we use in normal Python, but it's a little bit more powerful. So I'm going to put my values. I'm looking over here in my sheet. Oh, I had a 3 by 3. Okay, so it is, I need values for that. Again, I'm going to use R1, R2, and R3 as 10, 20, and 30. That just makes it easier. So my first row is 1, -1, -1. That's my, and see, that's a little list. And then I need another list, a section array, of R1, which is 10, 20, 0. And then finally, I need 0, 20, -30. And then I'm going to, let's just print that to show you that it actually exists. I'm going to run that. And there's a problem in that I missed my, that's my problem. And I don't know what happened there. Okay, there. So there, it doesn't look like it kind of looks like a matrix, but it's actually not a matrix. It's just an array that is in a matrix shape. So what do I need to do next? I need my, I need to find the inverse of this matrix. That's what I need to do. Then I also need my v thing. So let's do that. Let's put v equals, the v vector was 0. It's an mp.array. And it's just going to be 0, E1. Let's say it's 5 and 7 for the two E1 and E2. Okay, now let's go ahead and find the inverse of R. I'm going to call it R inverse. And it's linear algebra is a part of NumPy. And then I want to take the inverse of R. Is that the right code? Yeah. Inverse. Linear algebra inverse R, right? And let's just go ahead and print that, just so you can see what it looks like. Print R inverse. And you see it looks nasty because nothing's ever simple with this kind of stuff. But how about this? What if I take R inverse and multiply it by R? I should get the identity matrix. And let's do that. And then again, we do have to worry because matrix multiplication is different than normal multiplication. So we're going to use this NumPy function matrix multiplication. So let's just say R inverse equals np.mat, it's mat and mul, matrix multiplication. And then I need to give it my two things. I'm going to say R inverse and R. And let's print that out. Print R inverse. Actually, I did R inverse R, but it doesn't really matter. And then so down here you see, that's my, let's get rid of these other ones so that they don't cloud up our judgment. And you see that is the identity matrix. I have 1, then I have something that's super small, which is 0, 0, 0. Those are all zeros. Those are actually zeros, and that's 1. So 1, 1, 1. So it did work. Now what I want to do is to multiply. I want to say I equals R inverse. No, I want to do np.matmul R inverse and v, and then print I, and that's my answer. So those are my currents. Now let's just double check. So if I go back to my equation, I said number 1, I1 equals I2 plus I3. So this is I1 equals I2 plus I3. Yeah. So if I add those, that works. Okay. Let's just do one other one. Let's do this. Let's say I1 equals I0. 0 is the first element in there. I just want to type it out. I2 equals I1. I know that looks really weird. I3 equals I2. And then E1 equals, what did I say, 5? And E2 equals 7. And then I'm checking this one equation. So R1 equals 10. R2 equals 20. So let's do, I have this second equation. I'm just going to say print E1 minus I1 times R1 minus I2 times R2. And run that. And 0. So it works. Okay, so I feel pretty comfortable that that works. Okay. Now we're going to go over here and do our 5 by 5. So let's just remind you over here. I want to enter this matrix. I'm just going to go ahead and change my my R matrix to this. I'm leaving out the I, so it's going to be 1, -1, -1, 0, 0, 0, 0, 1, 1, -1, and remember R1's 10, -10, 20, 0, 0, 0, 0, 20, -30. You can see how it goes. Okay, so that's what I'm doing. So let's go back over here and do that. So I'm just going to go up here, R, there's my array. Now that's 3 by 3, so I'm going to make it 5 by 5. So let's just delete that and put 1, -1, -1, 0, 0. That's the first one. Now the second row is going to be equal to 0, 0, 1, 1, -1. The next row is -10, 20, 0, 0, 0. And then I have the next row, 0, 20, -30, 40, 0. And then the last row is going to be equal to 0, 0, 0, -40, -50. And then my V is going to be different, right, because I have 5 elements in there. I have 0, 0, -E1, which was, what was 5? -5, 0, -7. And after that, actually, everything's the same. I don't have to change the rest of the code. I can just rerun the cell. And I have an error because I put a dot where I should have put a comma. That's fine. And I have another error in that I have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1. Aha. No. So that was 0, 20. Oh, that was -30, 40, 0. You should have caught me. It's your fault. You should have caught me. There you go. Done. So there's I1, I2, I3, I4. Let's just check one of the equations. I'm going to look at this one equation right here. It is right there. And I want to do the same thing that I did right here. Let's just check if that one equation is correct. So let's just do this. I4 equals I3. And again, it's that weird thing. I5 equals I4. Okay. And then I'm just going to type it out. This is going to be -I3. Oh, let's just print it. Print -I3 times R4, which is 40, plus I4 times R4, which is 40. No, I3 times, this is 30. Plus I2 times 20. That should be equal to 0. And it is. I mean, -10 to the -15th is 0. Okay. So there you go. That's matrix operations in Python and solving circuit problems, complicated circuit problems with matrices. And you know, I think that you should understand how to do it the other way. I mean, this is just a shortcut way to do it. And if you just learn it this way, I don't know that you fully understand what's going on. Maybe you do, but it's the same math, technically. The only thing here is it's that finding that inverse matrix. I just don't want to do it, okay? But if I'm doing like a physics problem for a test and I want them to solve it in a normal way, I can do it this way to check. Because, you know, I already know how to do it. But that's it. Okay, hopefully that's useful. I'll talk to you later.